So, today what I was thinking is that since you know the network layers, right. So, in which layers how will you put the security, what is already there. I mean we do not necessarily put something in the layers until and unless the application demands it. Okay. So, why so? Because we rely on the already existing protocols that they will take care of the requirements. So, obviously, the network designers, architecture people, they have to think about all these different issues of security and where and how to put them. And all of you know that wireless networking is somewhat very different from our wired networking. So, the suites, protocol suites that we will see today, they are used for wired networks, and some equivalent wireless networking suites are also available, which we are not discussing today, okay, because the scope may be limited, that is why. And I just want to discuss these things because these you can take to be the basics, okay, and you can always develop upon these. Develop how? I mean it is not that they are all open standards, okay, they are not all open standards. So, you may not directly contribute to these, but what you can do is that from your application you can add, or I mean you can simply go on adding your own requirements on top of what is already provided. Okay. That means, from the application itself we may be very I mean responsible, we may be held responsible that why have not you supported this in your application, somebody may ask us, and since we know about the issues, so we can always take care of that additionally. I am telling you that this may be additional, but there is also need for that. So, let us start with the network layer protocols. In the network layer, as you all know, it is Internet Protocol IP. Okay. So, we have IP 4, IP version 4, IP version 6, right. Now, in the earlier IP versions, these security issues were not much dealt with. Why? Because it was never thought of. People used to take security to be as granted. That means, since all these handshakings and other things are taking place, so obviously my requirements are known to the application and the network, so it will be taken care of, just like that. And that is also because of the lack of awareness about security. Okay. But now, since attacks are also happening, and as we have discussed yesterday that there are so many different types of sophisticated attacks, hence the realization that the protocols in the layers themselves must have some security considerations also have dawned in, and that is why we have come across this IP security version of the IP. It has a security architecture obviously, which consists of the authentication header, the encapsulating security payload, security association and the modes of operation. Now, as far as the architecture is concerned, you understand that some header with some information and payload, that means the actual data again with some information will be there. So, these are the protocol suites belonging to the IP security, and the rest, that means the security association, that means how one end entity will talk with another end entity, what will be the algorithms, what will be some other issues that are to be dealt with, have to be decided, so that those findings and say requirements and parameters can be put into these headers, either the authentication header or the encapsulating security payload. And how will IP security work? It can work in two modes. I mean the modes available, as you all know, transport mode and the tunnel mode. Host to host is transport mode. So, IPSec is an end to end security scheme. It operates at the internet layer of the internet protocol suite. It is a protocol suite for securing the IP communications, because I have already told you that IP was there. Okay. So, in addition to that, some algorithms along with how to secure the data as well as how to guarantee that this particular sender has sent, all these issues have came up. That is why these are included in the IP security. Okay. So, it is a suite for securing the IP communications by authenticating and encrypting each IP packet of the data stream. So, authentication as well as authentication means, you remember, it may be part of your integrity, data integrity and origin integrity was there. Okay. So, authentication means you are telling that yes, this is a valid user of the system, and how you verify, not only you say that I am the valid user, but how do you prove yourself. Okay. So, and also the confidentiality of the transmission, all are included in IP security. So, encrypting each data IP packet of the data stream. And remember, we were talking about one way authentication and mutual authentication. So, here you see IPSec also includes protocols for establishing mutual authentication, right, between partners, and all these will be done at the beginning of the session. Pretty obvious that you cannot say start talking with somebody if you do not know how the other party is going to behave, right. And not only the behavior, but it is also in which language the other party will talk. Here the language is that protocol and the various requirements that we will each side will take. Plain and simple, you can say that as if there are different lists and each side will go on ticking the list, that I will take this, will you take this? Yes. So, yes. No, I will not take this, then another algorithm, just like that. Okay. And do not think that these algorithms are very say what shall I say, very not secured, I mean they are not at all hidden from the glare of the outside world. No, all of us know the algorithms, okay, but the implementation details may not be the same. We know the general working of the algorithms, but how is it actually implemented, that may be the part of these designers and developers. And so, the not only the authentication, mutual authentication, as well as negotiation of the cryptographic keys. So, negotiation of keys definitely therefore means that what type of crypto system will you use, public, right, or private, symmetric. Okay. So, that will guide how we will generate the keys and use them in the corresponding algorithms to follow. So, IP was developed, IP security was developed in conjunction with IPv6 and is therefore mandatory in all standards compliant implementations of IPv6. As I have told you, because nobody thought about it before, that is why. but its implementation is an optional extension to IPv4. This is also quite logical, that since I am having IPv4 and IPv4 also has some features. Okay. They may not be directly security features like that, okay, but they are able to meet some of the requirements for applications which do not require, say, very high level of confidentiality and other things. However, because of the slow deployment of IPv6, IP security is most commonly used to secure IPv4 traffic. That means, even now though IPv6 has come up very in a wide way, but IPv4 is also in use along with IPSec. The IPSec suite is a framework of open standards. It uses the following protocols. Now, remember, open standards, that means the guidelines what each developer will follow is open. So, you have to get your design approved according to the standard, because then only some particular buyer may get the protocol suite from you. I am talking about protocol suite here, but for open standards the thing is that the guidelines are there. So, if you want to have a product in the market, you have to follow the guidelines, because the customer who will buy, he will simply get the compliance check against the standard. And why the standard is open? Otherwise, anybody will produce anything. So, because of that. So, what are the protocols? Internet key exchange, obviously, this you may tell it to be a protocol, or it is just a part of the first one, negotiation and other things. Authentication header and the encapsulating security payload. So, IKE is used to set up a security association by handling the negotiation of protocols and algorithms and generating the encryption and authentication keys to be used by the IPSec. So, that means the security association between the communicating partners will be guided by this IKE. And how will it be guided? Because both the partners will choose, even before the data communication has started, what algorithms to use, how to use them. So, depending on those parameters, the keys will be generated and the algorithms taken up. So, that is the security association between the partners. Then comes the authentication header and the ESP. Authentication header, as you can understand by the name itself, authentication. Okay. So, it provides connectionless data and origin integrity for IP datagrams and provides protection against replay attacks. You remember replay attacks? Okay. So, you see here therefore, some measures have been taken up. People are understanding that if there are these certain types of attacks, let us see how we can deal with these attacks. And if we can deal with them from measures embedded in the protocol itself, it will be far easier. Then the applications do not have to think about that. Okay. So, that is why these things were ultimately taken up. Encapsulating security payload is used to provide confidentiality and may also data origin authentication and connectionless integrity. Similarly, an anti-replay service and limited traffic flow confidentiality. Actually, their usages, that means the AH and ESP, they may both be used or they may be targeted for particular situations as and when required. So, the AH packet, that means the header, authentication header, it has these many number of fields. Okay. Let us see what are the fields. Next header, Next header is an 8-bit field that identifies the type of the next payload after the authentication header. The value of this field is chosen from the set of the IP protocol numbers. Where they are defined? They are defined in some assigned numbers, which is the RFC from the Internet Assigned Numbers Authority. That means some standards authority. Okay. They have said that for this protocol, this number has been assigned, for such and such protocol this has been assigned, and for IP also there are so many versions and so many newer technological versions coming up. So, obviously, numbers may change, but here the numbers we know beforehand what numbers have to be chosen for which payload to be followed. Remember this line that this statement identifies the type of the next payload after the AH. So, that means what type of payload is coming after it, whether it is the ESP or the AH itself only. Okay. And in what mode of operation this particular communication bindings will happen, because security association always means the association between the communicating partners, okay, but for some particular session. Payload length, size of the packet, okay, and there are various reserved fields. Why? Because they have till now not been used, so that they can be utilized thereafter if necessary in whatever ways. Then the security parameters index. This is what we will describe. This identifies the security parameters which in combination with the IP address then identify the security association implemented with this packet. So, you see that I may be the source and I may talk with various different destinations, is not it? And with each of them my dealings may be different, right. I mean, it may be, I am not using that it has to be different, but it may be different, is not it? Suppose with X I am simply sending hi and hello, okay. So, I do not mind what algorithms are used and maybe I will take the default, okay. But with somebody, say I am exchanging some say very valuable data. So, of course, I will require some sort of security and then I may therefore mention some particular parameters that I want this algorithm, I want this type of key exchange and so on. Hence, it is written that in combination with the IP address, okay, identify the association implemented with this packet. Sequence number, we will see this SPI, since it is index. So, what do you think if it is mentioned as an index? So, basically it will be some number or something like this, is not it? So, how can we identify the algorithms and other things by a number? We will see it later on. Okay. There will be a sequence number for this packet, this is always there. So, it is a monotonically increasing number. And the authentication data, it contains the integrity check value that is necessary to authenticate the packet. Okay. This integrity check value, how will it be calculated? According to some algorithms, some keys as parameters which have been chosen. So, in this way your authentication header will be constructed. Now, we are coming to the ESP. Similarly, ESP also has more or less the same types of fields, obviously, because it will also require those fields, though its application may be in different. That means, it may try to encrypt the data along with some nominal authentications. Okay. So, obviously, all these fields will be there. So, the SPI again security parameters index will identify the security parameters in combination with the IP address. Sequence number of the packet will be there, payload data, that means the actual data to be transferred, and many a times padding may be required. Okay. It is used with some block ciphers to pad the data to the full length of the block. I mean, in block cipher particularly, since the data is divided into blocks and the entire data length may not be a multiple of the number of blocks. So, you may have to have some padding. Okay. It is a very common practice, and obviously, the length of the pad, right, size of the padding in bytes, because how do you know which one to discard as pads, right, that is why. And here also next header is there, identifies the protocol of the payload header, payload data. The value of this field is again chosen from the set of the IP numbers defined in the most recent RFC from the Internet Assigned Numbers Authority. And it will also contain authentication data, which is required to authenticate the packet. So, now let us see what the most important security association is. It is very, very important, because it will actually shape the the data, how it will go, how it will be received, what types of keys will be used, and how it will be encrypted, how will you authenticate the origin, and etc. All this is dependent upon this security association. The IP security architecture uses the concept of a security association as the basis for building security functions into the IP. Association is simply the bundle of algorithms and parameters such as keys. Obviously, the keys will always be the parameters to the security algorithms, different types of keys, okay, that will be used to encrypt and authenticate a particular flow in one direction. So, you see that this security association is defined for one direction only. That means, when I am sending, I am defining that in this way my data will go, say, from A to B. Suppose I am A. So, from A to B data will go according to this algorithm, this keys and such things to B. If my data goes to C, I may use some different algorithms and other things. But I am not at all telling how the data will come from B to me, okay, because I cannot tell that. That is the under the purview of B. B will decide how it will send data to me. Say, for example, say I am just giving this as an example, it may not be considered also. Say B always sends me acknowledgement, no data, nothing, but I always send very highly valuable confidential data. So, obviously, from my side I will be worried, much more worried, hence I will have a great many number of algorithms and etc. to make my data confidential and prove myself to be. But while B is sending only acknowledgement back, so why it will go with all these things, right? There may not be any requirement at all from the side of B. So, that is why the association is from the side of the sender. Therefore, in normal bidirectional traffic, the flows are secured by a pair of security associations, right? A to B security association 1, B to A security association 2. The actual choice of encryption and authentication algorithms is left to the IPSec administrators, okay. And IPSec administrators therefore you can think that okay, they are having a list and they are simply giving some tick marks. So, basically many of these are by default choice, as we can find out later. IPSec uses the SPI, Security Parameter Index, which is an index to the Security Association database. So, that is why I was asking that if index is a number, then what does it do? How do you actually get what to be used? So, actually there is a database and you index it using that SPI. So, you get, and remember you have the destination address also in the packet header. So, the sender along with the destination address, particular destination address, you index into the database and you get what is required for this association. So, there the algorithms are marked. So, are these all pre-planned? What do you think? Or they are prepared somewhere and then later on they are simply being saved into the database? What happens? At least the algorithms have to be chosen, the keys, and whenever you choose the algorithms, you know what type of keys are to be developed, right. If you choose say symmetric key algorithm, so you know. So, in the SADB the index will give you, from the SADB the index will give you the requirements for the transmission, which together, I mean along with the destination address, both of them will uniquely identify the security association for a packet. Now, just tell me one thing, that will it be done for each and every say communication? I mean communication in the sense, yes, say data 1 is going, after some time data 2 is going. I mean, what is the general perception? It should not be done, is not it? Once we have identified ourselves, we have authenticated ourselves, we have chosen, is not it? Some session concept may be there. Okay. Let us see what is there. For multicast, a security association is provided for the group. Multicast communication you know, and is duplicated across all authorized receivers of the group. This is also very logical. However, there may be more than one security associations for a group. Again, it depends on what type of applications these are going to be required, that is why. And many a times the group may be closed, sometimes the group may be a open group. Okay. There are several types of groups also. Now comes how IP security will work. IPSec can be implemented in a host to host transport mode as well as in a network tunnel mode. So, transport mode is used for host to host communications. Only the payload of the IP packet is encrypted and or authenticated. The routing is intact, since the IP header is neither modified nor encrypted. So, have you ever studied about this transport mode and tunnel mode? So, what is the transport mode? I mean, what happens? Do you remember? Is there any chance of changing the actual header in transport mode? What does tunnel generally mean? That you are not able to see anything, is not it? So, as if the, so data is inside the pipe. So, you have a covering. So, that is very clear. That means, original packet is there, you are getting a cover over it and you are sending it. What about this transport mode? In the original packet itself, you are trying to provide the, I mean whatever encryption, whatever authentication you can give. Now, you can understand that how this may be used. So, you see that in the transport mode host to host, the original IP header is kept and the entire packet is signed by the authentication header, and in the tunnel mode you keep that outside. Have you studied by any chance mobile IP or something like that? In mobile IP also this type of functionalities are present. Okay. These different modes and these authentication and other things. So, hope this will make your understandings clear, and generally I have just shown that these are the most general uses, but it does not mean that you cannot use the AH with tunnel mode or ESP with transport mode. Okay. It does not mean that you can use anything, but these are the general usages. Tunnel mode basically means you are putting your data inside an envelope. An envelope is the has the new address. So, the envelope will be detached when it reaches the new address and the data delivered to the actual receiver, because it belongs to that particular network or something.